In Lesson 3.1, Day 2, Examples 4 and 5, you will be graphing linear equations by finding the x and y intercepts and by making a table. In order to graph a line, you really only need 2 points. So if we find the x and y intercept, we can make our line. The x-intercept, remember, is when y is 0, and the y-intercept is when x is 0. In example 4, we want to graph 2x plus 4y equals 16. So I'm going to start out by finding the x-intercept. Remember, the x-intercept is when y is 0. So I'm going to go ahead and write an ordered pair that has y being 0. And then I'm going to go ahead and plug 0 in for y. So we have 2x plus 4 times 0 equals 16. And the 4 times 0 is going to just be 0. So it's really 2x equals 16. And then we're going to divide both sides by 2. And x equals 8. So 8, 0 is our x-intercept, or it crosses the x-axis at 8. So we're going to put our point there. Now the y-intercept. The y-intercept is when x is 0. So I'm going to plug in 0 for x. 2 times 0 plus 4y equals 16. When we simplify that, we end up with 4y equals 16. Divide both sides by 4. Y is going to equal 4. So our y-intercept is at 0, 4. So now I'm going to go ahead and connect those 2 points with a line. We're going to put arrows on the ends to show that it keeps going in both directions. You may want to pause the video and try the next 2 on your own. The x-intercept is when y is 0. So I'm going to go ahead and plug in 0 for y. Two times 0 is going to be 0, so we end up with this. If the opposite of x equals 3, then x is going to equal negative 3, because you could multiply or divide both sides by negative 1. So we're going to go to the x-axis and put a point on negative 3. Now the y-intercept, remember, is when x is 0. So I'm going to go ahead and plug in 0 for x. So we really just have 2y equals 3. And then we're going to go ahead and divide both sides by 2. And you get y equals 1 and 1/2. So we're going to go up to 1.5 on the y-axis, put a point, connect it with a line, arrows on the ends. In our next example, the x-intercept is when y is 0. So 0 equals negative x minus 5. You're going to want to add 5 to both sides to get x by itself. We have 5 equals the opposite of x. Therefore, x is going to equal negative 5. So we're going to go over to negative 5 on the x-axis. Right there is negative 5. Now for the y-intercept, that's when x is 0. 0 minus 5 is negative 5. So the y-intercept is negative 5. So we're going to go down 5, put a point, connect it with the line, and put arrows on the two ends. Now our last type is to graph by making a table. It says graph y equals 1/3 x plus 2. Well, we're going to make a table of values. We're going to choose some different numbers for x, plug them in, and see what y is. But since we have a fraction in front of the variable, we're going to want to choose values of x that will make this work out to be nice for graphing. So we choose numbers that 3 will divide into. So if you look at the example, they use -3, they use 0, 3, and 6. I would make sure you do at least 3 points, even though you only need 2 for a line. As long as you have more than 2 points in your table, you'll be able to find if you make a mistake somewhere. So they plug in -3 and they get 1, plug in 0 and get 2, plug in 3 and get 3, plug in 6 and get 4. Go ahead and plot all those points and they should be in a straight line. If it's not in a straight line, you made a mistake somewhere in your table. Let's go ahead and try these examples now. Now you could go and just plug in some different numbers for x and then go through and solve your equation to find what y is. But I'm going to show you a way you can rearrange this equation to start with to make it a lot easier. Usually when you make a table, if you have the equation solved for y, it makes things easier. So let's go ahead and do that first. If I wanted to get y by itself, I'm going to subtract 2x from both sides. When I subtract 2x from both sides, this is going to disappear right here, but then I'm going to be left with the negative y, or the opposite of y, equals 2 minus 2x, or a negative 2x plus 2. Now, if I want a positive y, I'm going to have to multiply both sides by -1. If I multiply negative y by -1, I get y. And if I multiply this entire side by -1, using distributive property, a -1 times -2x is positive 2x, and a -1 times 2 is -2. So this really is the same thing as y equals 2x minus 2. Now if I go ahead and plug in some numbers, let's try, for example, 0 for x. 2 times 0 is 0, and 0 minus 2 is negative 2. So we can plot 0, negative 2. So you're going to stay right there and go down 2. Now let's try a 1. If I plug in 1, 2 times 1 is 2, and 2 minus 2 is 0. So I'm going to go to the right one and then stay right there. Now let's try 2. 2 times 2 is 4, and 4 take away 2 is 2. So I'm going to go to the right 2 and up 2. You could keep going and do a couple more points, but I have an idea of where that line is going to go off of those 3 there. So I'm going to go ahead and connect those points to make a line. And again, arrows on the ends to show that it keeps going in both directions. Now the next 2 examples are a little weird. We had these happen in one of our previous lessons. When you only have an x, when you go to make your table, this is saying x equals 3, or x is always going to equal 3. Doesn't matter what y is, x is always going to be 3. So if I wanted to go and graph this, I just chose 0, 1, and 2 for y, but x is always going to be 3. I'm going to go right over here to the x-axis. I'm going to go to 3, 0, 3, 1, 3, 2. You'll notice you are making a vertical line that goes through the x-axis at 3. Put the arrows on both ends. So an equation that looks like this with only an x equals 3, it's going to be a vertical line going through the x-axis at 3. And then our last example, y equals negative 2. That means it doesn't matter what x is, doesn't matter what I plug in for x, y is always going to be negative 2. So if I go to graph these points, 0, negative 2, 1, negative 2, 2, negative 2, you're going to end up with a horizontal line that goes through the y-axis at negative 2.